This small gadget is the USB-A to USB-C cable tester, and it is there to identify what USB-A to USB-C cables are capable of, because just on the outside you can see what's on the inside and what the purpose of the cable is. And how it works is you just plug both ends in, so this is the USB-A side, this is the USB-C side, and then you just read the LEDs. In this case, this cable can only power the device or charge it. It can deliver power. There's also this RP indication, and this is specified in the USB-C specification, and it allows the device which is connected on USB-C to know that on the USB-A side there is something capable of delivering power. Now let's have a look at the next cable. So plug 1 and 2 sides, and this one can also be used for USB 2 data transfer, so high-speed USB data transfer. This one is also capable of USB 3 data transfer, so super speed, which is even faster. And finally, we have this cable, which has all LEDs on, so USB 3 and the shield indication. This means that both ends of the cables, the shells, are interconnected and they're both connected to ground. This is very important for super speed data transfer used by USB 3, and this cable is fully USB-C specification compliant. This is a good cable, and thanks to the tester you can test them. Now let's have a look at all the different versions. This is version 0, and you can always find the version on the back of the PCB. Here we see V0. And it was my first prototype. It worked correctly except of 2 aspects. The shield wasn't detected correctly. It didn't verify if both are interconnected and connected to ground, and this would lead to some false positives. The other problem was on the power. Not all USB cables, or at least some cheap USB cables, do not use all 4 ground and 4 V-bus pins which are in the USB-C cable, and this would lead to a false negative on the power detection. So it could transfer power, but my USB cable tester didn't verify it correctly and didn't light up. This is version 1, and again you can find the version on the back of the PCB. And this is now a fix of the version 0, where the shield is now detected correctly and the power too. And it has even a ground pad here, and this can be used in case the USB-C cable has shield which is connected from one end to the other, but they forgot to ground it and to connect it to ground. So how it works is that you can touch the shell to ground and then to the connector, and this way you ground the shield, or you ground the shell, and the shield will light up. So this is an additional feature. And by the way, there is also a QR code on the back, so if you want more information, find the source files and so on, just scan the QR code and go to the site with plenty of details. This is the schematic of the USB-A to USB-C cable tester, and it shows how it works logically. So here we have the battery, a CR1220, and it is connected to plus. Plus is also connected on the USB-A side, so this connector on the V-bus pin. And if the cable is connected, the V-bus pin on the USB-A side will be connected to the V-bus pins on the USB-C side, which is this connector. And this is connected logically to power plus. Power plus connects the LED to power minus, and power minus, which is here, is then connected to ground of the USB-C side, and if the cable is present, this is then connected to ground on the USB-A side, which goes to ground, and to ground of the LED. So if the cable is present, and if both wires are present, then the red LED lights, indicating that it can transfer power. Same happens with USB 2, where we detect the D- and D+ line, and with USB 3, we detect the RX+, RX-, TX+, and TX- wires within the cable. For RP, it's a bit more complicated because within the USB-C connector, there is a pull-up resistor on either CC1 or CC2. And if this pull-up resistor is enabled, here on RP, this activates this MOSFET, allowing power to go through the LED, which then shines in red. This is similar for the shield. In the shield, we have power going to this MOSFET, and this is only enabled if shield A is connected to ground. And then it goes through here, and the shield LED only lights up if shield C, this one is also connected to ground. So this means that both shields are interconnected and they're connected to ground. And then we have the shield LED going on. And that's basically how it works. And because this is open source hardware, you can find the schematics of all the versions, the board layouts, and plenty of information on the website.